Epic Online Services, or EOS for short, is a free service provided by Epic. They provide free leaderboards, stat tracking, achievements, anti-cheat, voice chat, matchmaking, and more. In this video, we will cover setting up Unreal Engine to use EOS, enabling and configuring the plugin, the developer portal, connecting to Epic Online Services, and logging in. If you like this video or find it helpful, consider subscribing and liking the video, and leave a comment if you have any questions or thoughts about what you want to see next. To get started, make sure Unreal Engine 5 is installed and that Visual Studio is set up. I will start by making a new level with the basic template and setting it to my startup and default map in project settings. In the plugins area, I will enable everything that deals with EOS and restart the editor. While the editor is restarting, let's use this time to look at the Epic Developer Portal. You will need to configure the portal to your account and create an organization. This is not difficult, nor does it take very long. Create a project and name it. Feel free to spend some time exploring the services Epic has to offer. In order to use the service, we will have to configure Epic Account Services. Let's start with linked clients and add a client to the list. Name it whatever you want and add a new client policy. Client policies allow the players to have access to different services. Give it a name, and for this example, we will use Game Client with Unlock Achievements. Leave the settings at default and select Add New Client Policy. Leave the next two fields blank and select Add New Client. Refresh the page, and now you should be able to add your client to the linked client configuration. For the permissions configuration, turn everything on. Don't concern yourself with the brand settings unless you plan to release the game. If that's the case, you can do this later. Now under the project settings, you will see all your ID keys. These will need to be copied into the EOS plugin in Unreal Engine Editor. In the editor, open the project settings and look for OnlineSubsystemEOS. Working from the top down, we will first change the default artifact name. You can name this whatever you want. Select Enable Overlay, Enable Social Overlays, and Enable Editor Overlay. Next, hit the plus button to add an artifact. Name this the same as you did for the default artifact name. Copy all the IDs from the developer portal into the appropriate ID places. For the client encryption key, you can leave this blank. However, Epic documentation recommends putting in 64 ones. While you're here, check all of the remaining checkboxes below. Now we need to manually alter the configuration file for the engine to tell it to use Epic Online Systems. Navigate to your default engine.ini file in the config folder of your project files. Open this in any text editor. Copy and paste the text that I have in the description. Save the file and close. As far as I know, it doesn't matter where you paste this in the file. Now let's do a quick check to make sure that the editor can see the Epic Online Service SDK. Open your output log and remove all the filters. Do not clear the log. Enable only the log EOS SDK filter. You should see that it is initializing some EOS SDK version. If you don't see this, try restarting your editor. If you still don't see this, go back and double check your ID keys and your default engine ini file. Create a new C++ class of the type game instance and name it appropriately. Personally, I don't like the live coding feature in Unreal Engine 5 and choose to disable it. If you choose to do the same, you'll have to remember to compile it in the editor. Go into Visual Studio and find the build.cs file for your project. You will need to enable 3 additional modules by adding them to your module list. I will post them in the description below. From this point forward, I will no longer be able to post codes in the description due to the length, but I will drastically slow down so that you may hopefully keep up. You may notice text popping up on its own in Visual Studio. This is because I am using the extension GitHub Copilot. I am not sponsored, but this extension is highly useful. It helps dramatically, but is not always accurate. In fact, in this tutorial, it was wrong most of the time, but it was very close. Compile in the editor to make sure there are no mistakes. If there are no issues, head over to the game instance header file. We will need to include some dependencies in the header. For now, include OnlineSubsystem.h and interfaces/OnlineIdentityInterface.h. You will get the red squiggle errors in Visual Studio, but they don't interfere with the code compiling. But to clear those up, close Visual Studio and Unreal Editor and navigate to your project files. You will need to generate Visual Studio project files again. Once you do this, wait for Visual Studio to fully load the project, and the IntelliSense errors will go away. Create a public section for your functions. I like to add a constructor, but it's not going to do anything. Also, add an initialize and shutdown override. Next, we will make a function to make sure that the Epic Online system is available. I will be using this in the blueprint, so we will need to make it blueprint callable, like I'm showing. Create the definitions in the .cpp file of your game instance. You can do this quickly by right-clicking on the green squiggles and selecting Create Definition from the pop-up menu. In the initialization function, just call super init and similar in the shutdown function. In the EOS available function, we will need to first access the online subsystem. GitHub Copilot was close here, but let's make some changes. We will need an OnlineSubsystem pointer that I call subsystem and set it equal to online::get subsystem and pass in the parameter get world. The error is because I need to include OnlineSubsystemUtilities.h. Now we will check if the subsystem has a pointer, and if the subsystem name is equal to EOS. And then send a message to the log if the EOS is available. We will compile in the editor and set it to use the game instance we created by searching for game instance in the project settings. For the time being, we will do our work in the level blueprint, though typically I handle this stuff in UI widgets so that there's simply a button to log in. In the level blueprint event graph, get the game instance and cast it to the one you made and promote that to a variable. That way we only have to cast once and not every time we want to check if the EOS is available. For now, we will call the function by pressing the 1 key on the keyboard. Get your game instance reference, and you will find that the isEOSAvailable function is attached to it. Press play and open the output log and docket. Clear the log and press the 1 key on your keyboard, and you should see a warning pop up that says that the EOS is available. This shows that our code was working and that we successfully connected to the Epic Online Service subsystem. It would be handy to actually log a player in. Let's create a blueprint callable login function. We're going to want an event to happen in the blueprint when the login completes. In the GameInstance.h file, above your class, you will need to declare a dynamic multicast delegate and name it fEventDelegate. This will be the event class that gets called in the blueprint once the server has responded that you have successfully logged in. Now in the public section of your functions, create an F-event delegate named OnEOSLoginComplete. We will also need a function to handle the login when it completes and a delegate handle. You will see how to use these momentarily. In the login function, we will once again need to get the subsystem like before. You will also need a pointer to the identity interface and a unique net ID pointer for the player ID. We can use the net ID pointer to see if the player is already logged in when attempting to log in. To do this, we will check if the net ID is not a null pointer and the identity interface states that the local player 0 is logged in. If the user is already logged in, we will display a warning error that the user is already logged in. Now we need to bind the delegate handle. A delegate handle holds until something else happens, and then runs the function it's told to. In this case, once it's notified about the FOnLoginCompleted delegate, it will create an object that will then run the handle EOS LoginComplete function. We are able to pass in command line arguments to change the way we log in. We won't be covering that in this video, but we are going to set up the code to handle that for later. Start by making an f-string variable, and then we will parse anything that's in the command line arguments in the editor. You can enter your arguments in the additional launch parameters area of the editor preferences. We will use an fparse to get the command line and look for the login type entered there. If the command line is not empty, we will attempt to use the auto login function for the first local player. If that doesn't work, we will log that it failed and clear the delegate handle and reset it. I will explain the auto login, which is used for the developer authentication tool, in a later video. If the command line is empty, we will use the account portal. We will set up some account credentials and attempt to log in player 1 with those credentials. This will open either a browser window, if played in the editor, to log in through the Epic account system, or an overlay if played in standalone mode. If it's unable to log in, we will log the error, clear the delegate handle, and reset it. Now let's set up the handle EOS LoginComplete function. In this function, we will once again need to get our subsystem and identity interface like before. We can log if it was successful or not. I just remembered that we will need our F event delegate to be visible within the blueprint. Let's go back and make that blueprint assignable. It's also a good idea to have a function that is called when login is complete. So to recap a little bit, when the Epic Online Service servers notify the delegate that login is complete, the delegate calls handle EOS LoginComplete. Handle EOS LoginComplete checks if it was successful or not, and if it was successful, calls the function LoginComplete. The LoginComplete function simply broadcasts through the event delegate to create an event within the blueprint. And then regardless of success or not, we need to clear the delegate handle and reset it. Compile and go to the level event graph. We will call the login function from the game instance reference when we press the 1 key. Test it out by pressing play and then pressing the 1 key. I got this error about saying that corrective action was required. If this happens to you, verify your ID keys are copied correctly and in the correct place. Close Visual Studio and the editor and generate the files again. This fixed it for me. Now I see my login successful log. We can finish up by binding the OnEOS login complete event delegate to the blueprint event. Link it to a custom event, and for now, we will print to the editor screen that we logged in. Now, after we log in, we can see that the logged in message only appears after login process completes and is successful. I think this is a good place to wrap up this video. In the next part, I will cover adding stats, leaderboards, and achievements using this platform. If you like this video or find it helpful, consider subscribing and liking the video so you don't miss when I post part 2. Please leave a comment if you have any questions or thoughts or requests about what you want to see next. Thanks for watching.